All right, we're going to take another look at vertical and horizontal change, and specifically, we are going to find the ratio of vertical to horizontal change for each graph. So this means for every unit we move forward, how many units do we move up or down as we travel from one point to the next? So first thing we need to do is find out what our vertical and horizontal change are. And to do that, we're just going to kind of draw in a little triangle, help us out here. So our horizontal change from point A to point B, and by the way, we're always going to be traveling to the right in these examples. So our horizontal change, our delta x, will equal, and we just count spaces, 1, 2. All right, so let's make a little note here. Delta x is horizontal change, and delta y is vertical change. Okay? Horizontal change, vertical change. And here, our horizontal change is 2 spaces. Just count spaces. So our vertical change, going down, delta y, is -1. And that's important. It's not 1 space, that's just distance. But you notice we went down. And that's why it's important we say that we're traveling to the right, because if we were traveling to the left, that'd be a space up. Of course, if we were traveling to the left, then our delta x would be -2, not +2. It depends on which direction we're traveling, so it's important. So then, our delta y over delta x, our change in y for every unit in change in x, is simply -1 over 2. It's -1/2. And if you look here, if we move 1 space forward, we move half a space down. We move another space forward, we move another half space down. So for every space we move forward, how many spaces do we move down? I'm just going to put a little. For every space forward, half space down. All right, let's take a look at the next one here. Here, from this point to this point, our horizontal change is 1, 2, 3, 4, 5, 6 spaces. And we're going forward. We're always going to count our horizontal change going forward, for now anyway. So that's 6. Our vertical change, on the other hand, going from here to here, is 0. We're not moving up or down at all. So our vertical change per unit of horizontal change, since there's no movement up and down over the whole course of the 6 spaces, then for every space there's also no movement. So it's still a big fat 0 right there. Okay, so let's do one more example here. Now, again, as a reminder, okay, we're always going to be moving forward. So from the point on the far left to the point on the far right. So as we move forward, there's our change in x, and we draw an arrow up here. That's our change in y. So let's see, and we'll just count spaces. Change in x, starting from here, 1, 2, 3, 4, 5, 6, 7. And change in y, 1, 2, 3, 4. So our change in y per change in x. So essentially we're taking this entire movement up and we're splitting it into 7 equal smaller parts. So we end up with 7 divided by 4, and that's what that means. 7 divided, oh wait, what am I doing? Upside down. 4 divided by 7. So it's 4 units of upward movement divided into 7 equal sized chunks. So it's like, there's 4 sevenths, there's 4 more sevenths, 4 more sevenths, 4 more, 4 more, 4 more, and then up here. So I have 4/7, and then we next have what? 4 more sevenths. That makes 8/7. Then up here we've got 4 more. That's 12/7. And then let's see, 4 more to get up to here. That's 16/7. And up here, see now we have 20/7. All right. And then up to here, that gives us 24/7. We're just adding 4 more sevenths every time we move a space forward. And finally, we get up to the end here, and that's 28/7 altogether. But we can reduce 28/7 because 28 divided by 7 is 4. So in the end, all these tiny little steps of 4/7 each add up to an entire upward movement of 4 spaces. All right, so I'll leave the rest of these up to you, and then you need to go ahead and check your answers afterwards. Thanks.